Hey class, so this is Mr. Schmidt. We're talking about the answer key for the remaining parts of our P17 homework. This next one is the conservation of energy for two different masses, okay? So what we're talking about is we have our stick figure and we have our boulder, okay? So we know those masses, we know the height that the boulder starts at, and we're assuming that conservation of energy is occurring. No energy is lost to the water or to sound or to heat. So we're going to go through this as a two-body problem solving for conservation of energy. Okay. So these are all going to start off the same. We're going to have the energy initial equals the energy final. Okay. In fact, I'm going to start using this for final. You could use that for initial, or you could just leave it blank. Okay, so that means that my potential energy is going to be the same for the entire one. So we have two different bodies here. So we're going to have to do PE of 1. Okay, this is what I'm calling 1, and here we have 2. Okay. Okay, and again, final. Okay, so that sets it up. Now we can start thinking about some of these variables here. And before I even go, we can think about what is already at a 0, okay? So this person is starting on the ground, so they have no initial potential energy. Everything is starting at rest. So we have no kinetic energy, okay? Now what's happening here? The ball falls onto here. So it is going to end up with no potential energy, okay? And as this goes through, this guy will be at his maximum height, or stick figure, we don't know their gender. The stick figure will be at their maximum height when they are not moving, okay? And this, again, will not be moving, okay? So if we're trying to find this, okay, what is the maximum height the second stick figure can rise? Then we can just go through and eliminate a lot of these, and we get a very straightforward question here, okay? So okay, so the final height of the person, okay? Then we can start plugging in our numbers here. So remember from up here, M1 was the 256 kilograms. H1 was 7 meters. H1 prime, 0 meters, okay, which is why some of these things zero out. M2, 64 kilograms. And we are looking for 0 meters, H2 prime. That's the big question here, okay? And then we're going to assume all the velocities are going to be 0. They start at 0, they end at 0, okay? We're not concerned about what's happening in between all those points. Okay, so now if that's true, then we can say that 256 kilograms times 9.8 times 7 meters equals times, and that's what we're looking for. Okay, let's multiply all this out, divide by all these guys. Okay, so that's the solution. Again, if we keep track of all of our zeros, a lot of these are going to fall out. But as we go through these questions, more and more are going to appear. Okay.